Welcome back to the 30-day scripting challenge. It is now day 18, and yes, I still haven't been consistent in uploads, but 12 more days left, and then the portfolio will be finished. So day 18 is a combat AI type thing, where this NPC here will chase after players and attack them when they get in range. So it's gonna be really simple, just two scripts. I would imagine when you think out whatever you're gonna make in your head. Just one manager script for the NPC and then one to handle it as it's set up. So all I did in the beginning of the video is I just made an NPC called Chase NPC. So anyways, to start, I'm just going to make a module script. Modules. This is going to be how we create. It's how we create the NPC class that we want. So I'll just be calling this combat NPC module, I guess. We'll just call it that, right? But now in my previous video, the tower video, I made this class here for our tower, right? We're gonna do the exact same thing, legitimately the exact same thing. So just to visualize it, the idea is we want to have this NPC constantly loop through other players in the game while it's alive and check if they're in range. If they are in range, they're going to chase after it, and then if they're in range to attack, then they're going to attack it. And then if anything else happens, then it'll stop attacking, if the player dies or exits range. So as a matter of fact, we can grab the player service here. So I can just grab players. And then to have the NPC chase the player, we're going to use pathfinding service. And then to loop through all the players in the game, have that be passive or run, we're going to grab run service. And then also, because we're going to be connecting a class to it that we want to have certain events to, we're going to also use the signal module that I used in the previous video. So this is the signal module that I made in the last video. It's how you can create custom signals. And then actually, instead of just grabbing replicated storage, I can just say script.catch. They're both in the same thing. Alright, that's all that we're going to need for our variables, and then we can just do the rest of the class setup, so just NPC. Oh! I'm sure I'm just going to rename it to NPC. I'm not going to call it NPC. I'm going to save myself. Let's say npc.index will equal to npc as for our object programming setup, and now we can pretty much start with the setup. So all we would do is just say eventually npc.new. This will create our new NPC, and obviously we want to pass in the model of the NPC, because this will be something scalable that you can use from multiple NPCs, not just one. So we'll say self equal to set model table. And then NPC, so self.model equal to the model, self.humanoid equal to the model first child class, and then we put in human, and then self.root, which is part equal to the model.primary part. Alright, so this is the basic setup that we're going to need for our NPC. So this will be used for its checking its health, and then also doing our distance checks between all the players, which is why we want these two variables here. Now we're also going to send in, actually, you could send in another table here that could pass in the stats for the NPC, such as how much damage you want it to do, how big the range is, and any other things that you want. If you want different types of NPCs, like a sniper or just a melee unit or whatever. But in this case, I'm going to provide hard-coded default values. So we'll say attack range. That will equal to, say 60, because that came to mind from the slasher from Tower Defense Simulator. That's self.detection range. In this case, I will just use this variable as how far the player needs to be, not how far, how close the player needs to be to the NPC in order to start chasing. So we'll give it a generous 45 studs, and then we'll say self.attack cooldown will equal to, and we'll give it a 2-second cooldown, so that way it'll seem fairly set, right? Alright, now we're going to assign some internal variables, and in the tower video, internal variables are addressed with the underscore here, so underscore target would be an internal variable. They're just variables that we only want to have accessed inside the script. So we would probably need the target, definitely, because we want to keep track of who we're attacking. Because unless it's a multi-targeting NPC, we should only be able to hit one target at a time. And then also, I'm thinking also keeping some internal variables for when we pathfind it, but for now we're just going to do self._target will equal to nil, and then keep saying it. It was the same problem I had in my previous video, but we're going to want to now put in our signals from the signal module here. For those who don't know, signals are basically these little things that we can fire to listeners. That's it. Yeah. So I will simply just give a couple signals like when the player enters range, player exits range, maybe when we attack, and then when the target is lost or when the player leaves the range. So self.player entered will equal to signal.new. Here, I'll just create the signal for us. Self.player exited equal to signal.new, and then we'll do one for when they attack, I guess, because we can attach some visuals to it if we want. And it'll also allow us to just verify our cooldown. And then we'll also do one for when they leave range. So self.target lost is going to equal to signal.new. And those are all the things as well. Okay, the final thing that we're going to want to do in our setup is just create a passive loop that will constantly be checking for players and running all of it. It's going to be like a main loop. So I'm going to put another internal variable called running, and we'll set that to true. And then we're going to put a loop here. And we did this for the tower, by the way. But I haven't made the actual loop, so I'll leave this blank. But I'll put a comment saying main loop will go here, because we're going to want the thing to be running all the time. If we don't include the loop, then it's just not going to run. Then we're going to alright, now we can make the main loop here. So I can just say function NPC and then underscore for internal main loop, just like that. And also I'll just put this right here and I'll add that. So now in our main loop, it's just going to be while true loop and putting all of our things in. So in this case, in our loop, we just want this to run while the thing is alive. So while self._running is equal to true, and self.humanoid is the thing, right? And self.humanoid.health is greater than 0 too. So this will just check if actually I can just say while self.running. So this will just check if the humanoid is alive and if this thing is running. So it's like 2 verification of this to make sure. And in here, we would probably include the rest of it. I'd either have all of the utilities put in here or have them be separated. But for now, we're going to use run service. Just run service, the heartbeat, wait. This type of loop, you're probably not going to see as much. It's a good way to utilize a heartbeat loop, like running every heartbeat while also putting checks in. But this one isn't exactly... Actually, it is disconnected. Sorry, I'm yapping about stuff that might not even need that. My brain's like all over the place. So, I'll leave a little log or backlog here. We don't want the NPC to find our target, so I could just say function NPC : update target, because we want this to find our player. So there's a looping method that you can use here. I forgot what it's called, but you put 2 values that are your control values that you compare to whatever's in the loop, and you use that to find the highest value or whatever you want. You'll see what I mean. So we'll find one for the nearest, a variable for the nearest player, and then we're also going to store the distance. And in this case, we'll provide math.huge because we want the one with the shortest distance. So we'll provide the largest distance as our start, right? We're going to loop through, so for _player in players : in players : get players do, and we're going to get the character. So local character will equal to player.character. Local humanoid part will equal to the it'll equal to character.primary part. Or actually, I want to put a check here. It'll equal to character and character.primary part. So that way we won't get a lot of errors in the output that are flowing and stuff. If you watch the previous video about the tower, then I'll know. So we're just going to check here if humanoid root part, then the local distance is equal to the humanoid root part minus self dot root, right? And then if I'll do self dot root dot position, and then we'll put all of this in parentheses, and then dot magnitude. Make sure you spell magnitude properly. We'll check if the distance is less than the self dot detection range, and our, oh, actually, what am I doing? I should probably change this to the, because we already have two distance variables, and this less than the distance, then we're going to set the distance equal to the b, and nearest will equal to the, and that's this loop. It'll run through all this, and then eventually nearest and distance will be the closest player to the NPC. Anyways, I'm now going to check if the nearest is not equal to the target. So if it's not equal to this target variable here, that means it's a new player. So actually, we need to check if nearest exists first. So if nearest and nearest, we'll say self dot player entered colon fire, and then the nearest. So we'll use this player entered signal, and we're just gonna fire that. So any listeners connected here will have this. Okay, well, I mean, I should probably take a class on how to, like, explain stuff better. So, we're gonna check else if the target, so in this case, if it is equal to the target, oh, actually, wait a second, I did this wrong. We want one for if there is the nearest, and if there isn't the nearest. So in this case, we put if nearest, then we want this, and then else if there is a target, then, sorry, I messed up there, because we want to know if the nearest the nearest player is not equal to the target, then we'll put the entered. But if there is no nearest, but there is the target, then we're going to do like the player exited. So self dot player exited colon fire, and then we're going to put in targets. And then in this case, I think we have one for target lost. Yes, so it's like self dot target lost colon fire, and then we're going to the targets. I'm here, we're just now going to put this to the nearest. And that's all for the updating target. It's just simply looping through all the players, finding which one's the closest, and then checking if they were the nearest and before or not, and then firing player into correct as it is. Collectively, oh my goodness, what was the word? Responsibly, brain's on a roll today. I just got off like a crazy Clash Royale session. Anyways, and now we're going to the moving logic, because now that we have our target, we want to trace the target. So NPC colon update movement. This will be for when we want to trace the target. We're first going to want to check if there isn't a target, then we're just going to keep the NPC where it is. And this is important, because we don't want to chase after it. If not self a target, then we're just going to move it to itself, so that way it doesn't it doesn't move to think something that isn't there. So if there's no target, it's just going to move to itself, and then because we don't want it to I'm tired of yawning. We don't want it to continue this difficulty. Alright, moving on. This is the rest of this stuff. We're going to use pathfinding here. We're going to get the character. We'll say character will equal to self.target, and then a dot character, because in this case self.target it's just the player. And we're also going to get the root part. So we'll say local target root is going to equal to character, and character find first child of class human. Oh my god. Okay. Now we're gonna check our distance. So local distance will equal to the parentheses. Well, the target root dot position minus self dot root dot position, and magnitude over here, and then we can check if the distance is less than or equal to the attack range. Then we're gonna want to start attacking. So forward, move, and then the self dot root dot position. This is another safety check here in case the range is changed and we don't want to start chasing after anything again. Now the pathfinding also, for some reason for start attacking. No, the start attacking is after. I'm actually stupid for some reason. Okay, now the pathfinding. So when you use pathfinding, it doesn't always give us a path, it sometimes errors, which is why you want to pathfind multiple times until it gives you a result, but you want to throttle it so it doesn't constantly spam pathfinding. So for the throttling here, you would just say if OS that clock, so you would get the now, minus the, let me actually just, I'm going to make a variable here, for our pathfinding and the data here, and it's going to be for when we last compute the path, so I'll call it last path compute, and it's equal to 0, and then we're also going to have one for the path that's taken, so stuff.underscore path is going to equal to that. In this case, we're going to have this set to the path that our pathfinding down here will generate. So you could use OS clock, or you could use take OS clock, which is way better than take you know what I mean? I just like OS clock better. So if OS clock minus self underscore last path compute is less than 0.35. If you use any time here, 0.35 is a short amount of seconds. You could use 0.4 to 0.5. However slow, fast you want pathfinding until you compute, I'll use 0.35 here because it's kind of recording or throttling and pathfinding. And if this does happen, where it's doing it too quickly, we're gonna assign it we're gonna give it this red flag, where if it has it, we don't want it to continue. So we're not gonna put this variable inside of our setup, it's only gonna act as a check. So if it has this variable, we call it last waypoint, right? In this case, it's where the last waypoint of the path is, right? If there is the last waypoint, that means the path is generated to stay right, or the path has generated. We're gonna say self.humanoid move to, and then self.underscore last waypoint. So just to summarize this little block here, if they have this last waypoint value, it means the path is generated, and we're gonna move it to it. And that's if this has met, if this criteria has met, where the last compute time is less than 0.25 seconds. Meaning it's been generating really quickly, and then you're going to, because if not, then it's going to cancel. And then now at the bottom here, we're going to set that last compute time to os.clock to the now, basically. Okay, now Pathfinder. Also, go to your workspace and make sure you have, pathfinding, use improved search. Make sure you turn this on. It makes pathfinding better. Okay, when you're making path, you create a variable and you would say pathfinding service for create path. Now this isn't the pathway itself. This is just the instructions that you want. So you put in, as the agent parameters, you would have the agent radius, which is the distance around the how far from the NPC to avoid obstacles. So we're supposed to select a 2, so that way it's just basically. Well, it needs to be a taver. What do I do? There we go. So agent radius will equal to 2, and then the agent height is, you guessed it, how tall it is, so we'll just say 5 height. And then this one's called agent can jump. Sometimes you'd have this to be false, but I'll have it to be true. And this will determine if the pathfinding can generate over obstacles. That will determine if the NPC can. Alright, now for generating our path. We would put it in a heap call to make sure that the path generates successfully, and if it doesn't, then read it. So you say a local okay or success equal to heap call function, and we say path for computer sync, which is the function to start computing the path. We'll put in the humanoid root part position, and then the target root position. So if success and path dot status is equal to enum dot path status dot success, then so you could enum dot path status will return to value success or no path. Success means path generates. Successfully no path, meaning it could not generate. If this is true, then we're going to now move the stop here. So we'll say local waypoint is equal to, we'll say waypoints is going to equal to the path : get waypoints. and then we'll say if the number of waypoints is greater than 1, then we're going to loop through them and move it, because if it's only 1, we're just going to move it to that single waypoint. We'll say local next waypoint to equal to, and our waypoints, not waypoints, 2. This is the next thing, right? And then we say self dot underscore last waypoint is equal to the next waypoint dot position. And then we're going to move it. So self dot humanoid, and then move to, and then self dot underscore last waypoint. So we're going to move it to the last waypoint. Now, when we put agent can jump, it doesn't automatically jump for us. We have to tell it to jump. So if next BP dot action, in this case, when we put in each waypoint, it's not just the position, it has other things too. Like if I were to print it out, you would see. So action tells us if it's just walking, jumping, or climbing. So if next waypoint action is equal to medium dot path waypoint action dot jump, then so self dot humanoid, and then dot jump will equal to true, and then it'll jump for us. Now to add our else, in case it is not successful, we're going to move it directly to the player. Now this isn't going to factor in if like the player jumps up to a higher surface and then the NPC can't move. You could do that if you wanted to, and honestly I think that might return one. But anyways, if you want to make sure that this works, we could just say real quick, we'll say local delay is going to equal 0.05, and then local retries is going to equal to 5, and local turn will equal to 0. Right, and we're going to repeat fast dot wait delay time, yes. And we're going to put this inside here until success. So we'll say if success, or actually no, if not success, then, well, as a matter of fact, I'm not even do any of that. We could say if current equal to retries, then break, then set current is equal to 0. Else, we're going to add 1 to the current count. And actually, I'll put it at 6. And that's that. It'll just do this 5 times until it says to stop it. Alright, finally, we can now make it attack. So, just not stop. Function, NPC, underscore, update, attack. So this will be to attack the player when they're in range. So, first going to verify the target. So, if self dot underscore target, or no, is it whatever it is? So if there is, what the heck you know? If there is a target, then we're now going to verify that they are in like time to attack. So if the cooldown isn't in place, so if os dot self dot underscore, and we'll put a variable from the attack to last, by the way, just to verify with thing self dot underscore like last attack. So put that to 0 there. So if what's the clock? Self dot last attack is less than self dot attack cooldown, then we're going to return so that they're able to. We got the character, self dot score target character, and then local character and character. Find first child of class. I probably should add a check for if there is any more. Let me go do that. Oh, I already did. Okay, if the human part exists with the distance, same statement, and pick up the magnitude here. We're then going to check if the distance is greater than the attack range, or actually if the distance is. Oh wait, what am I doing? This is equal to if it's less than self dot underscore the last equal to os dot block and self dot, which I do have one for my attack. There we go. Okay. Boom. And you can put visuals here, so if you want like an effect this still on screen this will work just fine. Alright, we'll make a quick cleanup here. We'll say function NPC for the story, and say self dot running please really false. And this will be when the NPC dies. But yeah, I think I might just have it stop targeting the player. So So you could just say updates target, or yeah, we keep chasing the player, I guess. We keep it away. Yeah, we could just have it. We'll have it just do that, so that way it stops the move. Okay, well that should be that for this NPC like creator, the class. We can now put it in like a service or whatever, but just gonna make a server script just to show how it'll work. So this will just be called NPC chaser, and we would grab NPC and say we'll test NPCs, but equal to NPC dot new, and then our model will be workspace dot chase NPCs that are folder before, and then now we can do all sorts of things like test NPC dot player. And also I forgot, we need to put in all of the functions for our main. In this case, we want all three of them already. So self underscore update target, updates movement, and then update attack. We want to have all this from possible. Alright, now we can test out all of the signatures. So let's see. This is when the player enters, and then the player is passed in, because that's what we're sending when we fire it, at mob.player exited. Wait, mob? Tower defense, test NPC player exited, connect function, player, and we may test NPC attached, connect function, and all the players are. We can have some print statements in here, so we could say print player entered, and then we have one. So print player exited, and then the player, and we can also print. Actually, wait. If we want it to attack, we want to do some damage to the person. We'll say like local unit, so it's equal to player dot character and player dot character time first child class humanoid, and say humanoid, and humanoid, and take damage, and 5 damage, just like that. Perfect. And then we can also print player hits, and that's the now I will go play test it and see. Yeah, okay, first error already. Preset one instance and whoops, HRP dot position. There we go. Let's fix that. So now with the force field, go over here because I want to test out the damage. So let's go walk in range with our NPC here. And alright, now we're over here. Oh, this should be primary parts. Oh yeah, that should be primary part, not the humanoid, because the humanoid doesn't have a position. Okay, and now let's go test that out. Okay, so it's definitely different from the player. We get the person here, but more error. So if there's not a valid number. Oh my goodness, I type in humanoid root part, but I get the humanoid instead. Oh my gosh. It should be a primary part. I typed in humanoid root part and then I get the humanoid instead. Okay, so I'm in range, but he is not chasing me. Okay, maybe it's because he's anchored. That could probably be why. Let's take a look. Maybe that's why. There we go. Now he's chasing after me. Perfect. So the issue was just that he was anchored. Okay, he's chasing after me, alright. Now if I walk close to him, then, yep, he is hitting me, alright. Or is he going to see me? That's why. So I'm in range here, and if I walk close to him, then he'll hit me every 2 seconds. And if I keep walking away, he'll just keep chasing after me, and now I can fire my gun at him. Okay, no I can't. He's invincible. He is invincible. Oh, no he's not. Goodbye. And then, if you wanted to clean things up here, you could just say test NPC humanoid dot guide next function. Then we can just say test NPC destroy. So that way it doesn't run all this when it does. Or you can have it automatically do that when it dies. You could connect that inside of here, but yeah, that's it. NPC system. Just to summarize here, it'll loop through all the players, and it's going to check if it is within range of it before it'll start attacking or start chasing, and it'll keep chasing after the player until it gets out of range or whatever. And then you could also have it play attack animations or walking or running animations, whatever, but that's just the core foundation of the NPC system here. So yeah, I mean, it detects the player, it chases the player, and it attacks the player. I'm pretty sure that was the prompt per se. So yeah, thanks for watching, and we're almost done with week 3, just a couple more days. So day 19 is custom animations for a character or NPC.
Okay.
That's really easy to do. Alright, let's see the next one. Adios.